Today in our physics practical session, we decided to step away from the abstract world of textbooks and equations to bring current electricity to life right on the workbench. Physics is an experimental science, and there is no better way for students to truly grasp how electrical energy behaves than by manipulating real components, routing currents, and seeing the immediate result of their calculations. The core objective of this practical exercise was to design, analyze, and construct an operational circuit based on one of the most fundamental pillars of electronics, Ohm's law. We set out with a specific, hands-on goal, to power two light-emitting diodes, commonly known as LEDs, using a parallel configuration so that they share current while experiencing the exact same voltage from our power source. However, before the students could pick up a single wire or component, we had to lay the theoretical foundation on the whiteboard, mapping out the architecture of our circuit.
UBTH staff school. With discipline, we shall overcome. Together we shall win. With discipline, we shall overcome. Together we shall win. With dedication we shall overcome.
To guide the students through the engineering design process, I took time to explain the circuit diagram on the board in two fundamentally different ways to compare their real-world behaviors. The first design featured our current limiting resistor network placed strictly in series with the LEDs, while the second design explored placing the resistor network in parallel configuration. This comparative analysis allowed us to dive deep into the meaning and limitations of different circuit topologies. I explained to the class that when components are wired in series, there is only one single path for the electric current to flow. This means the current passing through the resistor is exactly the exact same current that must pass through the loads.
Shall overcome. Together we shall win. With dedication we shall overcome. With love we shall win. Joining hands.
This led us directly into the advantages of our second approach, where we looked at the beauty of parallel distribution. In a parallel circuit, the components are connected across the same common electrical nodes, creating multiple independent pathways or branches for the current. The defining rule of a parallel circuit is that the voltage across each parallel branch is completely identical. This mirrors how modern buildings and household appliances are wired. Your refrigerator, television, and light bulbs all run on the exact same voltage line, operating independently so that turning off one appliance doesn't suddenly shut down the rest of the house. By mapping these two contrasting designs on the board, the students didn't just see lines and symbols, they began to get insights as to what will really happen when the design gets executed.
Together we shall win. With dedication we shall overcome. With love we shall win. Joining hands in brotherhood, we shall acquire knowledge. Knowledge for empowerment. Empowerment and good morals in UBTH staff school. With discipline we shall overcome. Together we shall win.
With our structural blueprints thoroughly analyzed, we turn our attention to the specific components resting on the laboratory desks. We are not quite at the final finish line just yet. Our project is a work in progress, and the students are about to put the finishing touches on their layouts, test their connections, and get their final circuit design. But the momentum, curiosity, and energy in this room are absolutely electric. The absolute best part of this entire project is that this is not just an exercise that gets dismantled at the end of the period. Once the final designs are fully completed and verified, every single student will be taking their custom-built circuit board home with them. It will stand as a tangible, functional trophy of their hard work, a permanent reminder that they didn't just memorize Ohm's law, series and parallel networks, or semiconductor physics for an exam, but that they used their own two hands to build a working piece of technology from scratch.
With discipline we shall overcome. Together we shall win. With dedication we shall overcome. With love we shall win. Joining hands in brotherhood, we shall acquire knowledge. Knowledge for empowerment. Empowerment and good morals in UBTH staff school. With discipline we shall overcome. Together we shall win. With discipline we shall overcome. Together opposition we shall overcome. With love we shall win. Joining hands in brotherhood, we shall acquire knowledge. Knowledge for empowerment, empowerment and good morals in UBTH, our school. With discipline we shall overcome. Together we shall win. With discipline we shall overcome.